Alright, so next up is the properties of parallelograms. Now there are a lot of things that you're going to have to memorize about parallelograms and then eventually squares, rhombuses, and rectangles. Each one has properties that are unique to itself, and they also share properties with the others. So let's start with the first thing that you have to have when you've got a parallelogram is the opposite sides. So say this top side and this bottom side, this left side and this right side, they have to be parallel to each other. That's where we get the term parallelogram. So that's the number one rule right there. Opposite sides are parallel. Then the next thing that you're going to know about parallelograms is that the opposite sides are going to be congruent. So we can put congruency markings there and there, and there, and there. Now, once we've done that, you can see that basically what we've done is we've created parallel lines with a transversal and a transversal, or parallel lines with a transversal here and a transversal here. So that now brings in all of our alternate interior, alternate exterior, corresponding, and same side interior rules. So what this means is that this angle, opposite angles, are going to be congruent. So now we've got three things here. We've got opposite sides are parallel, opposite sides are congruent, and opposite angles are congruent. Then the next thing that we do is we draw in these diagonals. So the diagonals run from one vertex to the opposite vertex. What we know about these diagonals is that they bisect each other. So since they bisect each other, this diagonal here, or this segment of this diagonal, is going to be congruent to that segment of that diagonal. We know that this segment here is going to be congruent to this segment here. And since the diagonals are basically lines that intersect each other, then we also know that we've got vertical angles inside as well. So we know that this angle here will be congruent to this angle here, and this angle here will be congruent to this angle here. So those are all the different things that you would want to be able to label when you're talking about a parallelogram. Now, another piece of information you're going to need to know with parallelograms is the idea that consecutive angles, or angles that when you go around clockwise or counterclockwise appear consecutively, they are going to add to 180 degrees. They're going to be supplementary angles. So in this example here, we've got that angle A is 120 degrees. Going clockwise, we get to B next. Since B is the consecutive angle to A, these two angles will add to 180 degrees. That means that B has to be 60 degrees. In the same sense, if we said that this is angle D, and we're moving counterclockwise from A to D, D being the next consecutive angle counterclockwise, this would also have to add to 180 degrees with this. So if A is 120 degrees, then D has to be 60 degrees as well. And you can see that D and B being opposite angles are congruent, so this tells you that this would be a parallelogram if those angles were true. Now in problem number 1, we're given parallelogram PQRS, and we're told that angle S is 64 degrees. It wants us to then determine what is the measure of angle P. So if we use consecutive angles, what we're going to do is we're going to say that P and S together equal 180 degrees. So it would simply be 180 minus 64 is equal to P. So 180 minus 60 is 120, minus another 4 is 116. So we know that angle P is 116 degrees. In problem number 3, we're being asked to find what are the values of x and y. So we've got to go back to our properties of parallelograms to determine how we're going to solve this problem. Here we're given the diagonals of the parallelogram. And what we know is that the diagonals of the parallelogram bisect each other. So we know that this is congruent to this, and this is congruent to this. So what that's going to do is allow us to write a set of equations. We're going to have x equals y plus 2, and we're also going to have y plus 10 equals 2x minus 8. Now this is where you've got to recall your algebra skills. We're going to use substitution on this to determine what are the values of x and y, because what we've got are two variables in two different equations. So we can see that this x has already been isolated. Since the x has already been isolated, we know what it's equivalent to. We know that this x is equal to y plus 2. So anywhere that we see x in this equation, we can replace it with y plus 2. So that's exactly what we're going to do. We're going to take that and we're going to replace that x with the y plus 2. That's then going to give us y plus 10 equals 2 times y plus 2 minus 8. And again, the reason why we do this is we can't solve an equation with two unknown variables. But once we have an equation with just one variable, we can go ahead and we can isolate that variable and solve for it. So we're going to go ahead and distribute this 2 through. We get y plus 10 equals 2y plus 4 minus 8. And then I'm going to go ahead and drop these parentheses and just combine like terms. So y plus 10 equals 2y and then minus 4. Now what I want to do is I want to combine the y's together. I just want to have one variable that I'm working with instead of the two separate y's. So since this one has the smaller coefficient, that's the one I'm going to move. So I'm going to subtract y from both sides. And that's going to leave me y minus 4 on this side and then just 10 on that side. So then I add 4 to isolate the y, and I get y equals 14. Once I have y equals 14, then I can take that into the other equation and I can solve for the x. So x is equal, instead of saying y, I now know that y is equal to 14, so I can say 14 plus 2. So then x is equal to 16. Now I can go back and check that this makes sense. So I can put 16 in for this, and then I can say 2 times 16 is 32, minus 8 is 24. So I get 24 there. Then 14 plus 2 is 16. So these two check out. These two segments are correct. And then over on this one, 14 plus 10 is equal to 24. And now you can see that these two segments have the same measure. And so I know that both the x and the y that it came up with are correct measures. In Theorem 6.7, what we're given is 3 parallel lines that are then transversed by this line and by this line. And then what we're told is that when we have this transversal here, the segment that runs in between the first and the second parallel line, and then the segment that runs between the second and the third parallel line, they are congruent. So what this means is that these lines are not just parallel, they're also equidistant from each other. What that then tells us is that if we take a second transversal and run it through, that the segments that are cut by these parallel lines, they are also going to be congruent to each other. Now they're not congruent to this one, but they will be congruent to each other because they are running through equidistant spaces. So if we look at problem number 4, we're going to apply that same idea. We're being asked what is the distance between the points E and H. And what we're given is that this line, this line, this line, and this line are all parallel lines. Then we're told that the distance between A and B is 2, between B and C is 2, and between C and D is also 2. What that tells us is that the distance between each of the parallel lines is equidistant. So we then know that if the distance between E and F is 2.25, the distance between F and G also has to be 2.25, and the distance between G and H also has to be 2.25. So if we want to know the distance between E and H, all we have to do is add up those 3 lengths. 2.25 plus 2.25 plus 2.25, and that's going to give us the length of 6.75.